for those of you that are completing your algebra sequence, your developmental algebra sequence at our school, is Math 95. The capstone project, the culmination project, the idea where you cross the pons asinorum, which is a benchmark that I think everybody should be able to do, is what I want to show you coming on up. So imagine with me, if you will, that we have this quadratic equation, ax squared plus bx plus c. What we're trying to do in a quadratic is primarily solve for x. What are the values that make this equation true? And when we find those values, we can solve all sorts of problems. We've learned throughout this process that we can solve in lots of different ways. We could factor, we could complete the square, and so forth. Well, I want to introduce you to an idea that will allow us to solve any quadratic. And it will work every single time. But in order to do that, we have to be able to solve it from this starting position for any variables or any numbers whatsoever. And if you can do this on your own piece of paper, without any help, then you can use this tool. You have my permission. You can use this tool for the rest of your life. So let's solve it here, and you can watch it happen. Well, I want to solve that. So let's go through and do some of the different steps that we have. Step one, I want to isolate the x squared term. The x squared has an a in front of it. So let's remove that a. How we do that is we divide everything through by an a. I'm going to complete the square in this process. In order to complete the square, we remembered that we subtract that constant from the end. It's a constant because it has no variable on it. There's no x, so it's a constant. So I subtract it from both sides to free up this spot. So I can turn this trinomial into a perfect square trinomial. How do we find that term? Well, we take this middle term, which is b over a, divide that by 2, and that produces a b over a 2a, and then I square it. So that's the perfect number that turns this trinomial into a perfect square trinomial. So I have x squared plus b over ax plus b squared all over 4a squared. And what I have to do, whatever I add to one side, I better add it to the other side as well. So I have a b squared over 4a squared minus my c over my a. Whew. I know this can be confusing a little bit because I have all these letters, A's, B's, and C's. And that does get confusing a little bit. But that's also one of the powers of algebra that allows us to solve every problem once for all. And so that's why we're using these variables A, B, and C to represent any particular number that we want to do. All right, I chose this number for a very particular reason, that this will allow me to create this. This is a perfect square trinomial. It factors down to x plus b over 2a squared. And then on the right side, I have a whole bunch of stuff there, so I can just kind of leave that there. I have a b squared over a 4a2 minus a c over an a. You can start to see that property where I take the square root of both sides. So I have an x plus a b over 2a equals plus or minus the square root of b squared over 4a squared minus c over an a. Solving for x equals minus b over 2a plus or minus the square root of all that stuff. And now it's just a matter of cleaning things up a little bit. So let's clean them up a little bit. Let's start again. I have x equals minus b over 2a plus or minus the square root of b squared over 4a squared minus c over na. To clean that on up right here, let's go ahead and multiply this one here by a 4a. Because I can add those two fractions if I have common denominators. So I need to multiply the bottom one by, I need to put c over an a, multiply both of them by a 4a. Oops, minus b. That gives me a b squared over 4a squared minus a 4ac all over 4a squared. Hope you can kind of see where that's going. Now I was able to combine those two fractions. Again, what we're doing is we're just doing some of our basic algebra tricks and tools that we've learned before just to simplify this as far as we can. I can divide that on up as the square root of b squared 4ac all over the square root of 4ac. Doing that because I see perfect squares down there. X equals minus b over 2a plus or minus the square root b squared minus 4ac all over 2a. And I can really see one more thing I can do. I can combine these two. So that x equals minus b plus or minus square root of b squared 4ac all over 2a. And there what I have is a solution for x in the lowest possible terms that I can come up with. So I have x equals minus b plus or minus b squared minus 4ac over 2a. I have a solution for x. And we call that the quadratic equation, which tells me that if I can see any quadratic in this form, I'm able to find their solutions by using this particular statement, this particular formula, if you will. Okay, now you will use, and you can use that formula, but I want you to feel guilty using it until you can solve it step by step all the way through. Because once you solve it all the way through, then you're able to combine everything you've learned up to now to solve one of the more fundamental usages, problems, formulas that we have at our disposal. And if you solve it, it's not going to look like it's made up stuff. You solved it because you built it. It's a tool that you have, and it's a tool that makes sense.